Well, hi, good morning. Thanks so much for coming and joining me here while I fight my battles with these radios that come in my shop here. Now, this particular radio didn't battle me very hard, just a little bit, but he succumbed and started working. So, just to make things more complicated now, the owner of this radio has brought over this battery, there's a term for it, battery replacer. Not the proper term. For crying out loud. Okay, just started on my coffee this morning, so I haven't got enough in me yet. So this guy is all about being able to run a battery-operated radio from the mains, to speak like somebody from Britain. There's the plug. There's the on-off switch. Oh boy, that stuff looks old. Wow. This would have been probably from around 1929, 1931. I don't really know. It's basically a transformer, a rectifier, and I don't know what else is in that box. I can see the rectifier tube right here. And you can see the outputs written on it right there. So let's start taking a close look. This thing weighs a ton. It's a ton. It weighs. It's heavier than this radio. It's a lot heavier than that radio. So let's start by taking a look at what it says here. I'm sure you can read the word Hammond. Hammond, as far as I know, Hammond is a Canadian company, a very old Canadian company, and it's been building transformers forever. And so, and other supplementary stuff. I think they're well known for transformers. So, if you do this kind of work, you've probably had a Hammond transformer in front of you at some point. So let me get out my close camera here. Where is it? It's sitting way up in the sky here. Let me pull it out. Take a good look at this thing. Good. Model S-135. The Hammond, 110 volts, 25 watts, 25 or 60 cycles. That's kind of interesting. Hammond Manufacturing Company, Guelph, Ontario. And there's what's called an HEPC approval number. HEPC stands for Hydroelectric Power Commission. We could add of Ontario to the end of that. B. There's a big B on it. So I think this would be the B battery. Look at what they did back in those days. They put these little decorations on here. Oh, come on, camera. Put these decorations on here. Yeah, this camera has a bit of it's seeing a little too much. So let's look at the outputs here. What do we got? We got 45 volts. We've got 67 volts, we've got 90 volts, we've got 135 volts. So that looks like 3 different B voltages that could be taken off of this machine. Maybe if you have a different radio, you use a different voltage. 90, this one says 90. 90 would be the most common, I think. And maybe the reason for that is batteries came in 45 volts. So if you put two 45 volts in series, you get 90. I think 90 is a pretty common number. And I guess just, they're going to make this device, they're going to build it with a range. So 135, 90, 67 is kind of a weird number, isn't it? Why isn't that 65? Why would it be 67? That's kind of weird. 45 minus B and ground. What's the difference there? Minus B and ground. Well, this is old enough that the 3-prong plug grounded hydro system didn't really exist back then. Everything was a two cords. Oh boy, plug this in. Let's rush and plug this in right away. Yikes. Just how original is this? Very original. What I'm going to do is I'm going to stop for a second. I'm going to fix the focus on my camera so the automatic focus doesn't go back and forth on it. Okay, that's going to work a little bit better. So, prop, P-R-O-P-P, number 86. Never heard of that company. Oh, there's more on the back here. Same thing. It's a number 66. 125 volts, 3 amps, 250 volts. I'm not sure what it's made of. Could be Bakelite. I'm not sure what that is. Okay. Still clicks. Clicks in one direction. Doesn't click in the other. Who knows what condition these things are in. Then we take a closer look at the wire. So, you know, I am on my way to plugging this thing in, probably. Let me just get some cutters here and cut away some tape. I wouldn't plug this in until looking it over very carefully and maybe doing some preliminary tests on it, because the cord itself is actually in not bad shape. Oh, it's got writing on this too. Halero? Halero? Halero. I want to bend the wire to get a look at that lower part. It's upside down. Same word. Something. Halibro. Halibro. Looks to me like you could plug that in safely. Some interesting stories on the internet about why there's holes in these plugs, why there's little holes in them. Interesting thing. Okay. What else can we find on this? Find out anything else. There's a vent hole there. Vent holes on the sides. Vent hole on the back. There's where the cord's going in. Pretty amazing this thing isn't just one big gigantic rust bucket, but whatever they painted this with just really held up over the years. I don't think this thing has been taken care of in any particular way. I think it's probably been shoved around here and there. Well, I'm going to take the top off. We are going to peer inside. I don't know when the last time was this thing was open. Want to hazard a guess. You see the hole in the top where the tube is. Now I pulled this when the owner brought this over. I reached in and pulled the tube out. I discovered that this funny shaped hole in the top is so your fingers can go in and you can grab the tube. I'm not going to pull the tube out right now because when I pulled it out, the tube only had 3 pins on it, not 4. It's a 4-pin tube. Where's the 4th pin? It stayed in the socket. It turned to, let's call him Mr. W. And I said, see, this is the thing about this old stuff. You just never know what is going to happen while you're working on it. So it's so easy to generate problems as you try to fix problems. At least it is for me. Yikes. Wow. Yikes is right. So what this is, you would call this potted. So you can see the metal pieces here. It look like they're probably welded or somehow fused to the outside. The transformer has been dropped down in here. and then they've potted it with some kind of compound. It's very tarish. A very tarish compound. You can see some cracks in it. Probably shrinkage cracks. So, wow, you know, if there's a fault in the transformer, yeah, that's about it for that. I mean, I know you can melt this stuff out. Oh my gosh, stuff like this was used on the power system that I used to, for the company I used to work for, and it was regularly melted out, but it's a, you know, it's a semi-industrial process to melt that much stuff out of there. Wow, look at this. Yeah, like this. Yeah, wow. That's about all I can say. You know, something a little different going on down here. You can see in there a little bit. Looks like another transformer. It's like one they did in pot. What's going on here? Oh, there's that screw terminal here with something hooked up. There's another terminal here, nothing hooked up. And these look like terminals that should be slipped on. There's no way these wires aren't long enough. They are where they are. But there's no terminal coming up through. Yeah, actually, if you look down the crack here, you can see, it's a little hard to see maybe in the camera. I can see with my eyes. It's clearly a transformer down there. The windings going this way. And the iron core going across, the laminated iron core. I could lift these two screws, but we can't get this off without dealing with all this stuff, bending all these wires. Not a lot can be done inside here, I think, without huge risks of messing it up. Similar to what happened when I pulled this tube out. So, I'm going to pull it out. Oh, I didn't put it in very hard. I put it back in. Come on. It's the 3-pronger. Prong number 4 is still down there. So what kind of tube is this? Now this looks like, I don't think there's a tube name identifier on it. It's a funny red, like it's been spray painted or something. And this must be the kind of material. Yeah. It's a beautiful bakelite base here. Nice, nice red color to it. Yeah, a little hard to see in the camera. Very nice. If you had a radio that looked like this, it would be quite nice. Now, it so happens that a tube that looks just like this came out of the radio I was working on. I'll bring it over. Well, I'd say they're identical. Raytheon BH. And made in USA. No, I don't see it anywhere. No labeling on this one. What are the chances they aren't exactly the same tube? Very small. Look at them. They look pretty much identical inside. So what these are gas rectifier tubes. They don't have a heating filament. They don't need it. They have a gas inside them, and that enables the rectifying effect. Exactly how they're structured here, why they have this hat on the top, I don't know. You can see there's a post. There's 3. Let's see. Well, let's try to figure this out. There's 3 wires coming up through the tube. Kind of reddish colors right in here. One goes up inside that white thing, and the other one goes up inside that white thing, and there's one going right up the middle, which is holding on to the hat at the top. The glass goes right up inside those, must be ceramic tubes. So they're all kind of speckled. Both tubes, they look the same. The ceramic isn't, it's speckled a bit. somehow you'd think it'd be perfectly clean. Let me move this out of here. And you'd think it'd be perfectly clean in there. There we go. There. You can see the evacuation tube. See that glass dome at the bottom here. If you look inside, you can see there's a glass pipette, I guess you could call it. Comes up, bends, and then is open. Right above my finger there. And that pipette, if we took the base off, you'd see it protruding through the bottom of the tube. And then it would be sealed off. They would have melted it and twisted it and sealed it off. And that's how they, well, I was going to say that's how they exhausted this tube, but the tube's not completely evacuated. It's got a gas in it of some sort. So they probably evacuate the air and then allow gas in and then seal it up. Well, I can hardly see any reason to be scared to try this, except there's only room for 3 pins in there right now. I have to get the other pin out. Should we take the bottom off? Can we? No, I don't think you can. There's no screws. Of course, you can't get the bottom off because you've poured all this black compound in here, which has gone down onto the bottom plate, and the whole thing is fused together that way. So, I guess in knowing that, they didn't bother. However they did this, maybe they spot welded it or something. Well, there we are. Where's the big capacitors? There must be some capacitors. And so this is probably the transformer. This is probably the capacitor. And this is, I don't know what this is. This is probably 1 transformer, 2 transformers, and why would you have 2 transformers in this thing? There'd be no real reason to have 2, because you could have 1 with all these windings. Yeah, maybe I can find some more information about this schematic or something like that. But guess what? It's not the only one I've got. I've got another one here. Let's bring it up. I acquired these at a yard sale pretty much by accident. I stopped at a yard sale a few years ago, and there at my feet was a box with an old radio-like thing sitting in it, and a tube, and some stuff underneath, a small box. And I said to the yard sailor, "What do you want for that?" $5. Got it home, and when I took the thing on the top out, which is way more worth $5 to someone like me, it's really an interesting. It's a TNT ham radio transmitter from 1920 what? I don't know, 20 something. I'll have to have that in here at some point. These 2 things were underneath it. 2? Yeah, I have another one of these. So let's take a look at this one. I think this is fairly well known. A Mercury Power Box. For use only with 25 or 60 cycle alternating current, input voltages 110, 120, input watts 20 watts. Frequency cycles, what did I say it again? 25 or 60. Why do you got to repeat that? Oh, HEPC approval number. So this was sold here in Canada, but it may not have been made here. Oh, Toronto, Ontario. It was made here by the HM Kip Company Limited. The Kip Company. Never heard of them. Don't think they survived all the way to here. Okay, so it has a very interesting on-off switch. Check that out. I mean, that's 1920s. That's early 1920s, you know, how you turn your light on. Looking for any more writing on it? No. Okay, we can get the top off of this. Now, I showed this on my channel right when I got it. Look at the corrosion on this. Oh my gosh. Where has this been? Yeah, I'm not about to plug this in. That's not what's happening here today, but we're going to take a look at it. because this is the same sort of thing, but different. And then it's a battery substituter. Battery eliminator, that's the word for it. Battery eliminator. You get tired of charging up your radio batteries? Go down to the KIP store and buy your battery eliminator. This guy is also incredibly heavy. He doesn't want to come out and play. On-off switch. Yikes. Okay, so big problem here with this. So you don't want to break these wires right at the transformer, or you have a heck of a time dealing with that. And this wire looks like it's not got a lot of life left in it. Pretty flexible, actually. Surprising. Okay, let me put this down somehow. Strain the wires as least as possible. Okay. Wow, okay, there's some interesting stuff in here. Let me switch to the other camera again. No hint of a date on here, is there? HEPC approval number. What are the chances those things are on the internet somehow? Probably pretty low, actually. So what do we got here? So we got things are not potted. Got the transformer. Terminals at the back. It's got numbers there, 220. 220. I don't know how 220 fits into this. This didn't list its output voltages. I didn't even see where they are. They must be on these wires. Okay, so let's look at the wires here. Oh yeah, so that looks like that's set up to screw right onto the terminals in a radio. Look, they're fixed in order and everything. So this probably came from a radio. And one would be B plus, maybe the detector voltage. And A, right, an A voltage. Okay, down here, number 35. Is that two transformers just stacked on top of each other? So, primary and a secondary, what have they done? Looks like two different transformers. Can't see through here. Look what's on the other side. Oh, a rectifier tube. I didn't realize that. You know what? It must be the case that I've only opened up one of these. We'll open up the other one in a bit. So here's the other end of the terminal wires. Coming over. Back of that. Considering how old it is, it's in pretty good shape. Let's see how many pins come out on this. I'm not going to pull it out. There's no reason to. There's something to read back here, though. Condenser block. Aerovox condenser block. Brooklyn, New York. So Hammond in Guelph, Ontario was buying these from a company in Brooklyn, New York. Because Hammond didn't make capacitors. And I really think that's weird. You can build it. A transformer, but you can't build your own capacitor. There's not much to a capacitor. There's the wires down below. This would be a real piece of technology here. Oh, what's it say on there? For underground. Does that say sex? Okay, we have to pull this tube out. Let me just get it here. Okay. What does it say? For identification under guarantee, serial number. There's a serial number on this. And what does it say? Full wave. Oh, that's interesting. Full wave. The 125, the CRA 125. Oh. It looks pretty much the same as the other tube. It has a stabilizing structure in it to stabilize the hat. The other one didn't have that. 4 wires. 4 wires. Well, it doesn't have the centerpiece. Instead of the center post, like working like an umbrella, they've got 2 outside posts. Probably give much more stability. Maybe they want to get the wire away from where it was in that other design. For identification under guarantee. So selling tubes in the early days was a bit of a dirty business. Tubes were not very reliable. Expected life might be 1,000 hours, and maybe after 50 hours, it's shot. So you take the tube back to your tube selling store and say, hey, I only got half the mileage out of this. And they would award you with a little bit of money towards a new tube. But they had to know you bought it from them and when you bought it. Pilot, another thing from the U.S. Always been a ton of trade between the U.S. and Canada. For the longest time, in both directions, each other was the other's main trading partner. And today Canada is still right at the top of trading partners with the United States. It's I'm not sure the order now, but the 3 players are China, Mexico, and Canada. That's who the United States trades with. Everybody trades with China. I think. There's some more numbers. Well, I mean, it looks to be in fine shape for what it is. Let's go around this side. What do we got over here? Oh, more writing. Oh, check this out. Whoop. Look at that. Video technology at work. The high volt polymet filter condenser. Type, capacity, working voltage. So type C capacity is 0.1. Working voltage 1,000 volts. From the Polymet Manufacturing Corporation, New York, USA. Well, I guess just welded right onto it here. Okay, that's kind of interesting. We got room for another one? Not really, I gotta put this one away. So I don't think I'm gonna do anything with this. I'm gonna keep the tube out for now. So I'm just gonna throw the lid back on top here. Just loosely. Would this beast ever be put to work? Gee, I don't know. Now this one I think is different. This one has a loose top. I'm pretty sure I've had it off. There's the terminals. No identification. What? Nothing whatsoever. Nothing. That's kind of odd. Yeah, this one is quite different. This one has some different technology in it. Toby A block, not less than, and it's stamped in 4,000 microfarads. The Toby Dushman, Canton, Massachusetts. Another American piece. R and C. Not sure what R and C would be, but watch what that. Look what's on the other side of this one. Oh my gosh. Tain't no rectifier tube in this one. What do we got there? So, certainly this is a rectifier. Look at it. Look at it. Look at the bolts going through this. Oh, yeah. Various slices of stuff in here. Everything from metal plates to some kind of brownish material. Then in between the brownish thin plates is even more thin stuff. So, what kind of rectifier would this be? Well, as a wild guess, this could be a copper oxide rectifier. Apparently, the right kind of copper oxide can allow electrons from the metal inside out, but will not allow electrons from outside in. Or vice versa, whichever way it is, I don't know. This is an extremely rugged looking thing. These big pieces here, I don't know what kind of material that is. Feels like a sanding block is what it feels like. It's got a little control here, a little resistor. It's got a hole in the bottom, so you can adjust it. Almost certainly that's to set the voltage, I would think. It's a pretty simple transformer, not much to it. Just a couple leads here. Where's the rest of the transformer leads? Shouldn't there be? Maybe they come right out the bottom? No, there's nothing under here. Oh, wait a minute. Yeah, it's just this wire I can feel. The wire's underneath. How does this transformer work when you only have two wires going to it? Is that a great big choke? Is this the filter? No, unless I'm wrong, and this isn't a rectifier. I don't know what else it could be. Perhaps it's a selenium rectifier of a sort. I don't know. Pretty interesting stuff. So I think what I'm going to do is I'm going to stop and do a little research on the internet. See what Mr. Google can tell me about this guy, and especially this one over here, the one I really intend to actually try out. Yeah, I'm going to stop and see what I can find. Maybe it's a good time to drink a bit of coffee too. Well, my search for information about any one of these three devices has turned up nothing. And the Hammond Transformer Manufacturing Company is kind of swamped by the Hammond Organ Company on the internet. Of course, we all know about Hammond organs. So not related, two completely different companies. But I did find a piece of memorabilia for me to look at. I'm going to share it with you here. So this is a site about Toronto history, and this is focused on the company I used to work for, Toronto Hydro, and that's an example of one of our power stations, which was made to look like a house, but inside there is no house. There's a couple of transformers inside there. These are some of the other earlier power stations. I've been in these buildings. I was in them regularly. These were ongoing power distribution centers, if you like, with high voltage coming in and the transformers inside and then the lower voltages going out. This one in particular is on Yonge Street, and people driving by it would think it's some kind of a library or something like that, but the building is just a shell. Inside it's all hollow. There's transformers out in the back and stuff like that. So I don't know when this was built probably says here 1930. Yeah, so rear view. Some more shots of houses that are actually power stations. That's what it looks like in the backyard if you went back there. I like to keep the transformer outside in case it blows up. So this is the architectural drawing of the head office that I worked in. I worked on the 5th floor of this. The 5th floor was actually the 6th floor. I think I was up in here somewhere. In the engineering department. In the distribution design department. That's the building there that I worked in. I worked in there for, well, I worked for the company for just under 30 years. I spent most of it in this building, and my window for my little spot where I sat would have been this window right here at one point. Although, of course, you can work somewhere for many, many years, you move around, but always up in the engineering department. This is the Maple Leaf Gardens, the famous hockey arena in Toronto, right here. That's it. A little memorabilia. Look at those cars. Yeah, no, I didn't drive around in a car like that. There's a streetcar. Streetcars still run by on this street. Bear with me for another minute while I enjoy my own memorabilia. Toronto Hydro Corporation building right here. We're going to take a look at what it looks like now. There it is. There's a transformer vault out front. Some guy waving at us. Yeah. There's pictures of people working for Toronto Hydro. Power to Power Joy. What the heck is that? Yeah, so right downtown Toronto. And there's the streetcar tracks still running. And do we see a streetcar? There's one there, a modern streetcar. That's the entrance to the subway there. And that's Yonge Street for those of you who are Canadian and you're trying to orient yourself. That's Yonge Street running up and down there. This is Carleton Street running here, and College Street is over there. Okay, let's get back to what we're trying to do here. Okay, going down memory road there. I had a great time working at Toronto Hydro, and did lots of interesting things, which I won't go into. Okay, here we go. I have an interesting slideshow I'm thinking about turning into a video at some point that talks about the corrosion work I used to do at Tnt Hydro, so I'm still thinking about doing that. So what are we going to do here? First I got to pull the pin out of the socket down there that stayed behind. Can't say in all the years I've been doing this kind of stuff I've ever pulled a tube out. Oh, look at that. This one's really shot. Hey, this has got that nice... Oh, this is the one with the nice red base. I didn't notice it was loose like that. So if you get a tube that's loose like this, okay, the tube is not necessarily shot, as long as you don't turn it too far. All that's happened is the glue has given out between the base and the glass bulb. And it's quite common for this to happen. So you can imagine the wires kind of stick out the bottom of the glass bulb and find their way into these pins where they've been soldered, except for this pin. So what you do with something like this, I mean, you could try gluing this to steady it up. I think the main thing you want to do is just avoid twisting it. If you twist it far enough, obviously you'll twist up the wires and break something too. So it doesn't mean they're shot, doesn't mean they're leaking gas. Sometimes when you shake a tube you hear stuff rattling. Sometimes you'll find it inside the glass, which is not a good thing. Sometimes it's stuck in the base, and it's kind of harmless in a way, as long as it's not pieces of metal rattling around in there, whatever it might be. Okay, so that guy's out. We don't know what value it is, but we have two here. This one says BH, and this one says CRA125 full wave. But inside they look pretty much like they're the same thing. So I can do a little research on these tubes. Ooh. Yeah, don't see anything in the glass bulb. So this is probably rattling around in the base. I gotta wonder what all that is. Oh, this one sounds musical. That sounds like it's in the glass bulb. Down here. No, I don't think so. Oh yes. So can you see this on the camera? Only if I hold the bulb correctly here. There's a bit of tiny specky debris hanging in here, sitting at the bottom of the... There you can see it. You can see it kind of falling as I turn the tube. And I can see it with my eyes quite clearly, but if I go like this, tap it a bit, it disappears because it's all fallen down here. What is that? I don't know. Are these tubes any good? I don't know. Okay, I'm going to do a little tube research on the BH, Raytheon BH, and the other one. Yeah, but just before I do that, I mentioned the TNT transmitter that was in the box that contained, not this, but the other two battery eliminators. Here it is. I'm just going to show it to you, and I've done a video on this where I just checked it out very thoroughly. This is in really rough shape, you know, stuff. It's in rough shape. Came with a tube here, a tube extender or a tube converter base, and on top was a tube, and that's what I saw sticking out of the box was this tube. Turns out, and I still have it, that tube is a WD-11. WD-11 is a very, very early tube, and unfortunately I tested it. It has an open filament, I believe, so it's not any good. But TNT does not stand for trinitrotoluene or whatever. TNT stands for something else, some kind of transmitter. So maybe someday, you know, when I first got a hold of this, boy, there's no chance of me trying to do something. Look, there's one of those resistors, only this one's been soldered in. I think this is a transmitter. Son of a gun. I wonder if it... No, it's got to be a transmitter. Look at the size of this up on the insulators. I'm pretty sure it's a TNT transmitter. This will be home built. Okay? It's just on a breadboard, piece of wood. This was some ham radio guy's ham radio one time. No doubt doing Morse code with it. No way you're going to be hooking a microphone up to that. So I just wanted to show you that because I mentioned it. Okay, now I'm going to go look into those tubes. So here's the Radio Museum information about the Raytheon BH. And I think one of the most interesting things is to read the description here. A full-wave cold cathode rectifier, BH, from Raytheon was developed for use in B battery eliminators for radio receivers. It handles high peak currents of 80 to 90 milliamps, up to 125 with a maximum peak plate current of 400 volts. Whoop. But needs proper elimination of RF noise by proper shielding and filtering. See also the Telefunken RG1500 or the Z80. I've heard of a Z80. Introduced in 1926 after the introduction of RCA High Power Audio Triode 199. First advertised in October 1926. There's another website here where at one of the tube selling places, and they were recommending this tube for use as rectifiers and guitar amps. What? Really? So I have another page on this that I found. Take a look at it. Okay, we have to credit somebody for this. We will credit whatever that is up there, Museo del Pro. I don't know what that is, but anyway, that's where I got this from. BH full wave gas rectifier. BH was the high current evolution of the very early cold cathode gas rectifier. The Type D, introduced by Raytheon around 1925, intended to be used as a B plus battery eliminator, or used in B plus battery eliminators. Type BH was rated for 125 milliamps DC output current. as in other gas rectifiers of the same family, the B and the BA, the large cathode surrounds small anode tips. In this type, the cathode is dome shaped. Read it like it is, Joe. In this type, cathode is dome shaped, and the two anode rods are protected by ceramic insulating sleeves outside the cathode dome. Okay, well, that's exactly what it is. Data type. That shows you what it looks like. Cathode and two plates. What kind of gas is in it? Cold gas rectifier. It doesn't actually say what kind of gas is in it. Did it say over here? Oop. To 1945 rare. Didn't look rare on eBay. There's all kinds of them for sale on eBay. I guess these tubes are quite rugged. There's no filament to burn out. Let's see what we can find out here. A gas-filled full-wave rectifier tube, cold cathode type requiring no heater supply. Voltage is designed particularly for service in B battery eliminators for radio receivers. Type BH was developed primarily as BH battery eliminators and has a typical characteristic of all gas-filled rectifiers as regards a constant voltage drop and the ability to handle high current peaks, high peak currents. Any tendency of the tube to generate RF noise may be eliminated by proper shielding and filtering. BH is filled with a permanent gas rather than a vapor filling. Well, what gas? They didn't say. Some kind of secret about what gas was in there. Okay, so that's I think what we're going to find out about it. I'm going to guess that other tube, usage and models, according to their database, this isn't necessarily the be-all and end-all, but in their database, so it gets kind of popular in radios right around here. Well, I think it's time to try this guy out and bring it up on voltage and see what comes out of it. And I think I'm going to want to look at it on a voltmeter and probably on an oscilloscope and just see what the signals look like, or the voltages that come out of that look like. Of course, it'd be a no-load thing for a first test, and the like. I'll get that ready to go. Okay, I think I'm ready to go. Now I'm going to be using this guy here. I've never really used it for what it's intended for because I have the dim bulb system that I am usually using, and I've got my oscilloscope ready to go, and I've got this meter ready to go. This will show us the B+ output. This is on the 150 volt scale, and I've connected it up to the 135 output. And there's my voltmeter probe, my voltmeter probe, and my scope probe. And they're grounded back to the B- terminal on the guy. So, and we have this guy set for 5 volts per division, so it won't be long, and DC. It won't be long before this is off the scale. Let me just drop it down like that. It's probably just going to go up. The idea of this is to see what kind of hum or how well filtered it is, if it's filtered at all at this point. So I'm going to use this. I'm going to reduce the output voltage down to nil to start. Then we can watch the current draw as I advance it. I won't know what voltage we're getting up to, but when this white dot, which you can barely see, gets around to the red mark, which you cannot see, that's 120 volts. So we're not going to likely to get that far. Who knows? This is fuse protected, and behind this is another isolation transformer. So even though you see this a 3-prong plug and alike, there is no third prong coming. Got the on-off switch here, which one button is red. You'd have to guess pushing the red button turns it on, so I think it's turned on, but let's turn it off to start. I'm going to plug this guy in here. I think that's in. Okay, you may also see this meter come up. This meter is, a friend of mine built this meter for me. This doesn't start at 0. This starts at 100 volts and goes up to 140. So so this won't move until there's enough voltage there. It's hooked up. It's basically reading the voltage at the outlet here. In fact, this gray plug is what's going to this meter. So it's reading it right at the outlet. That was useful before I got this fantastic box here, which I'm not going to go into right now. This is my SDR radio. It's here because it's here. That's the only reason it's here. It's just here because it's here. And these little screws over here, these are all the things I never got back into radios I worked on. Uh-oh. They're collecting at the side of my bench. Don't you have a collection like that? Okay, I think we're ready to give it a try. Looking everything over. Okay, so I'm going to apply 0 volts. It may not be absolutely 0. Okay, I'm running it through these dim bulbs just in case something wild happens. And nothing's happening anywhere. Okay. I mentioned that this did I say this won't be reading the voltage? It's going to read the voltage at first. But I can flip it here and it'll read the current drop. Let's see if we get anything happening here with just a little bit of voltage. So I'm watching this meter very carefully. I see nothing happening. Nothing happening on the scope. The unit is switched off. Okay, let's switch it on. Nothing happened whatsoever. Okay, we're going to raise up the voltage and watch this meter here. Oh, you can't quite see it. Watch everything. Watch everything at once. Okay, so I see nothing happening. Maybe you're seeing this meter too. This is another meter that measures the voltage at the plug, but this is more a percentage meter, oddly enough. So 100% is 120 volts over here. So these are gain meters that I used a lot before I got this guy here, and of course this guy here, and all kinds of other guys here and there and everywhere. So we're going to watch the current on this. This is 1.5 amps full scale. Any current flowing. Okay, we're cranking it up fairly high now. There is some current. It's hard to see in the camera you're looking through, but this meter is going up a tiny amount. So if this is a 1.5 amps scale, that's 1 amp, half amp, quarter amp. We're up around 75 volts or so, I would think. We're up at 75 volts. I see no rise on this meter. Let's make the meter more sensitive. Okay, it's come up a tiny amount. But it's not related to this. It's probably just a bad zeroing of the meter. Looks like no output. Now, why would that be? So we're actually supplying it. We can read on here 60 volts. This guy won't work until there's enough voltage to make it operate. So I guess 60 volts is enough. Well, it could be maybe this one terminal is not working. Maybe I've picked a terminal that doesn't work. So let's poke around with the voltmeter here. Okay, we'll leave the 135 connected to the scope, which hasn't moved at all. Scope's on DC. How am I going to see the, yeah, DC, right. Everything's fine. Okay, 60 volts coming into it. Anything here? You're watching the meter here? Here? Anybody, anywhere? Anybody? Somebody, anybody? Okay, so I'm using the B minus terminal as the negative side for the voltmeter now. Certainly sounds like a good idea. So we know we've got AC volts coming to this terminal. This one is open. Okay, this is suggesting something. Let me turn this down again. Let me turn it off. Power off. Okay, so no power in the outlet anymore. You know, why would they put that terminal there and then hook up nothing to it? Because this thing is busted and somebody removed the wire from this terminal so nobody would plug it in and fire it up. Is that true? That means this other wire should be laying just down there ready to be fetched. Okay, and the power is definitely off. Here, let me just, it's absolutely off, but it can't be any safer. Pull that out. Let's go looking. Are you down there? Okay, so there is a wire, but I don't think that's the one. I can see nothing. I can see nothing. Let me try with a close-up camera here. See if we can see a little more with that. And how about some light? How about some light? Well, you know, the wire comes in, it's tied in a knot. One leg comes up here. Oh, there is a mark. There's a mark right there. Looks like H. That looks, oh, the other way around. That's an L. Low, high. So probably what this is if your house voltage is low or high, you move this to where you want it. The house voltages these days are regulated quite well. You know, it's always within a pretty close range, like in my house right now. The voltage is just under 120, about 117. It's about what they aim for. So the other lead wire is connected somewhere down under, and we can't find it or see it. I could move that wire to the low terminal, but I might break it. I think we're going to end up concluding that this guy is just not going to work. Goodness knows what could be wrong with it. Down in all this gook. A lot of terminals here. I could take readings on these terminals. Maybe I'll grab my so where is it made? Oh, for crying out loud, I didn't plug the tube in. Okay, hold on. Well, that's good. So we've completed the test without the tube in. We will now place the tube inside and continue our testing exactly as planned. Okay, I'm going to grab a tube. I'm going to grab the Raytheon tube. Going in. Hopefully all 4 pins will come out. Okay, we're ready to cook now. Now we are ready. Okay, so we'll plug it back in. This is down. Turn this back to output. Hook up the voltmeter again. Okay, there we go. One more try. Okay, voltmeter still set to 150 volts, full scale. We're on the 0 point here. Power on. Going through those dim bulbs still, because I'm a chicken. Here we go. You're watching this guy. You're watching everything. Watch everything. Watch the scope too. Here we go. We're going. I'm going up. Nothing's showing up. Maybe there could be a strike voltage on this. You got to get it up so high so that this thing will actually start operating. So, well, that's scary. You get a whole bunch of voltage here. This thing starts operating, and then whatever's wrong with it shows up. That's a scary thought. And I'm leaning right over top of this thing too. I'm gonna get a blast of black crap in my face. Okay, kind of current. Watching the current meter. Yeah, there's some current there. Same as last time. Maybe it's just some inductive current. The on-off switch is on. My little meter can't handle it yet. It's all 8s. Where are we here? So we're putting in about 60 volts. Let's keep going. Oh my gosh, there she goes. Just like I said, it struck. Oh, that scared me. Quickly, what's the current? What's the current? Oh, backwards? How do you get it backwards on here? How does that read backwards? What happened there? It's a funny button push. Okay, so we're reading on here now a very, very small current because it's a 1/4 amp there. So we're reading about a 1/10 of an amp, about 100 milliamps flowing. Anything weird happening? What happened up here? This just went up, didn't it? Let's go back down. Once these things, I'm assuming what we experience here is the tube started conducting at a certain voltage, but there's like a hysteresis type thing. You can go down a lot lower. Let's just go down. Oh yeah, look at the scope there. Okay, there's still a touch of voltage. No, so it stopped. And what are we up to? Oh, bing, there it goes. Okay, now. So we're running the guy with still very low. Let's go up, 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 up. Okay, you can see what's happening here. This is on a 150 volt scale, and we're up at 120 volts on the 135. This thing might be bonkers because I raised the voltage so slowly. So we can't use this. It's not going to come back. It's bonkerized. So there's 135 on the output. It's totally hum-free, but there's no load on this, so that shouldn't be too surprising. The input voltage is only 85 volts. My gosh, if I raise that up to 120, we're going to get 200 out of this. Amazing, eh? Absolutely no... Oh, son of a gun. There. No sign of a hum on this. And the 5 volts per division. 20 volts. Wait a minute. How can this be 20 volts? What have I got my guy set to here? So what I'm talking about is the scope lead. Oh, that's why. I had it on times 10, I think. So I put it on times 1. But I can only do 5 volts per division. Okay, so if it's times 10, then we're looking at 50 volts per division. That's 200 volts. That's one. What's going on? I don't know. Not to worry too much about that. Well, I don't see anything really terrible happening here. Let's look at some of the other voltages. Okay, I'll leave the scope connected. Let's check this one again. So 130. I get everything in the view here. 130. The 90 is, hey, the 67. How do you like that? Only the 135 is producing. How come? Wow, you'd think if one worked, they all work. Wouldn't they? It's all these terminals here, I think. That's a 135. 135. Lots of 135s. That's an AC. Can you see how the meter's kind of jumping and then just goes back to zero? Jumps a bit and goes to zero? That's a DC meter reacting to AC. And that's the same thing there. So these are probably going to the tube rectifier. The output's probably coming back here somewhere, somehow. And then what about this? What's that arrangement for? This is probably AC here. This is probably ground. This is probably AC. Happen to have an AC voltmeter. There it is. Doesn't go very high. 50 volts now, full scale. What happened there? So on the 50 volt scale, you know, that's all of a big whopping 10 volts. Don't know what's going on. That's going to be 120, I'm pretty sure. Or no, I'm not 120, it's going to be 80. So these are really weird. That's weird. What's going on with my meter? Where can I get really, this would be the supply voltage right here. That's supposedly 20 volts. I don't get it. That's okay. What are we going to do with this thing? Is there some simple, like really far-fetched that these wouldn't produce any voltage, but this one does? I mean, what's going on there? Come on, AC. That's what's going on there. 130 volts. These other ones don't do anything. So I would guess if you plug this just in the wall, let the 120 AC volts come into it, you're going to get 200 and something volts out of here. And the radio over here is not looking for anything like that. In fact, the radio with the proper tubes in it is looking for 22 volts of B plus for the detector. With an 01A in there, apparently you can go quite a bit higher. Actually, it wants a little more voltage. So maybe 45. So you could drive that with the 45. If there was 45, I don't think it's going to work for us. And as for repairing this, that's really not in the cards here. Not in the cards. Well, that's the situation. Okay. I think that's enough for today. Enough for me. Not sure what I'm going to do now. Think about all this. Let all this stuff cook. Often, just like for everybody, I'm taking all this information, and then during the day, little bits and pieces kind of come together. And I start realizing, hey. So maybe that will happen today too. Maybe we'll figure something more out with these guys. So, thanks a lot for watching. I'm not powering up that radio today. I don't know. Don't know what I'll do next. Think of something. Have a great day, and I'm very sorry to hear about the terrible storms in the United States and how people's lives will have been turned upside down right here in the Christmas period in a terrible, terrible way. So very sorry about that. And see you tomorrow.